So the remaining challenges for LNR is there's no generally accepted theories. There's three major theories right now that are being proposed, but it may be a while until it finally gets figured out. We're going to have products on the market before we know what the theory is figured out. And another factor is anything with the word nuclear in it scares people. It rightly should. So that's a problem we have. But what we really need are the investments of an industry, the $20 million and going to Brilliant and also into the work of Rossi's. There's been a lot of media attention to it, and it was really negative in the early years, but there's been some really positive media from several news sources. But if you go out on the internet, you can read all types of, quote, experts that say, this is just baloney. It's just fake science. And I might have thought that had I not been following a couple of years. But when I went to that conference last year and I was around the people that worked in the industry for 5 days, and Dan was there with me there, it was enough to say, no, this is real. So what can LNR be used for? Well, it's going to be used for heating, for one, because it's just so easy to do. And then another one is a heat source for thermoelectric generators. And there's a thermoelectric generator. Here's one. I'm going to just pass it around. Frank, pass that around. And that's an electric generator. There's no moving parts there. One side you make it hot, one side cold, and you generate electricity. Here's one you can buy commercially, 550-watt thermoelectric generator. It uses natural gas. They use this out in the boondocks where they don't have electricity to create power. And then also, what's unique about thermoelectric generator is that it just uses a difference in heat. Here is just a regular old heat sink. The temperature is the same temperature as what is in the room right here. And here is a thermoelectric generator, similar to what I'm going around here. And here's a little LED light bulb. There's a little circuit on here which increases the voltage, but it doesn't create any electricity. And there's a little C on there. So if I put the C down here on the heat sink, and then Frank, if you put the palm of your hand on the top part, and we're generating electricity there. You can see it in the little LED light bulb, generating electricity there, just by the difference in temperature of him, and you're about probably 98 degrees, I would guess, or so, and the room, which is 70 degrees. What is that? About 30 degrees temperature, generate electricity. No moving parts. No moving parts. How efficient is that? Poor. It's typically 5 to 8% efficient right now. But they're improving, and they project that these will be 10 to 15% efficient here in a few years. So take a difference in temperature, no moving parts. This stuff gets hot, put two together, hey, you have an electric generator with no moving parts, or maybe a fan to keep the heatsink cool. So heat source also runs Stirling engines. Here's a little engine made by power technology, cyclone power technology. Can use heat from a device like this and turn a generator. Steam source, you can use LNR to generate steam. The guys at Industrial Heat trying to generate 1,000-degree Fahrenheit so they can redo the power plants that we have. We have probably 7 or 8 power plants in the state of Iowa that use 1,000-degree temperature to generate 600, 700, 800 megawatts of power. That is an incredible thing. Heat source for absorption chilling. Heat source for desalination. How many places in the world don't have enough water, but they're right next to the sea? Power source for ships and trains. They use a tremendous amount of heat. Power source for an automobile, and power source for airplanes. By the way, do you know how much power is in the jet engines on like a 777 jet? Anyone take a guess, the 2 jet engines, how much power they have? 120 megawatts. 120 megawatts, which is what the town of Cedar Falls probably uses on a peak day in the summer. It's about their peak load. So incredible amount of energy used in transportation. And lo and behold, people are working on that. Hard to believe, hard to believe. So the cost of the fuel, this stuff, nickel is abundant. hydrogen's abundant. It's going to be less than a quarter, 25 cents a million, where natural gas today is running about $5 a million. So what's the impact on the fossil fuel industry? Well, here is just a guest editorial in the journal called the Journal of Petroleum Technology. These are what the oil guys read. It says, if LNR works, the impact on the petroleum industry, power generation, coal industry will be enormous. Even wind farms and other emerging alternative energy technologies could not compete economically with LNR. I don't know about that or not. But anyway, and I said, when the Wright brothers flew their first plane at Kitty Hawk, North Carolina, the scientific community reportedly argued for years after the fact over whether a heavier-than-air flight craft could actually fly. Even the most obvious evidence was enough to make some people abandon their preconceived notions of what was possible. That's what's happened to this. We have abundant evidence right now of fusion occurring. But how come I'm not a physics professor up here from one of the major universities talking about this? It's just an electrical engineer that knows nothing about it. Why am I up here rather than somebody else? That's just the way the scientific community oftentimes works. And they went on to say, hey, you guys better position yourself for this. And Statoil out of Norway is positioning themselves for this. So what's the impact on the utility industry? Well, the most immediate application for LNR will be commercial industrial process heating, which uses gas. So I think this is going to reduce natural gas sales for large industrial customers. This could take a while because these boilers aren't for free. It's going to take some investment to pay for them. The electric utility industry is in dire need of an alternative to burning coal. They really are. They all know it. They see the handwriting on the wall. They got to wean themselves off of coal. This is it. This is the gift from God for the utility industry, I really believe. It's going to allow them to use the great equipment they have, central station power, to keep generating electricity for years to year. All the infrastructure set up there, the only thing they have to do is rip the coal-fired boiler out and put a new boiler in. Everything else stays the same. Except they won't be a unit train of coal cars coming in twice a day or every other day. You can drive all the fuel you need for a year in the back of your pickup in for the power plant. The utility industry needs this. And so, and they also have a bunch of nuclear power plants that are getting old. And some of them are really have tremendous expenditures for upgrading their reactors. Some of them, they just close the reactors down when they look at the bill for fixing the reactor up to extend their life. So again, this may be the source for it. And the smaller distributed generation, there are going to be products out in a year or two, from the George Miley out in Urbana, Illinois, to generate electricity. It's not going to be economical for you and me to do that. It's going to be cheaper just to leave our electricity hooked up. But there's lots of places around the world where electricity costs 50 cents a kilowatt hour, $1 a kilowatt hour instead of 10 cents a kilowatt hour. In those places, this is going to be a great gift. So it will take longer for this LNR to affect the retail electric markets, but it'll be a gradual transition, and I think it'll give plenty of time for the utilities to get adjusted to it. So my concluding thoughts, it's real. It was a tragedy that the world did not start working on LNR in 1989. It was a tragedy. I think the University of Utah screwed up. I think that was the issue. It doesn't appear that nuclear safety concerns will be a major issue. They've talked about this before. Been some investigation into it. It doesn't seem to be a big issue. The Chinese are going to be using this technology. One of the companies, Industrial Heat, I believe, is working with the Chinese. It's going to raise their standard of living. And in fact, eventually it's the poorest people on Earth, my opinion, that are going to benefit the most from this, the poorest people on Earth, because they don't have electricity and they oftentimes don't have clean water. So, as a power engineer, and I'm not a nuclear engineer, I'm a power engineer, and I'm extremely gratified to be able to witness this energy transformation in my lifetime. That is, if I don't get run over by a Mack truck going on the home tonight. So, thank you very much for your attention. I wanted to point out that we have a a guest in here that I didn't realize that was here until he showed up, but a person that runs one of the websites that talks about the ECAT, the Rossi, it's called ECAT World. And Frank Ackland lives down by Lamoni. Stand up, Frank. Actually has this website. It's a really good website. I've been on it many times. And he is kind of like me. He's just extremely fascinated by this. And he can't wait for the world to adopt this technology. So appreciate Frank coming up here today. And Frank probably knows more about this and could give this talk better than I could. But anyway, thanks for coming up for the presentation.